Good day, everyone. We will be looking at integration by completing the square method, mathematics N6. So that's a problem that we have to handle. As a mathematics N6 student, your formula sheet plays a big role. So if I want to integrate this problem by completing the square, the first thing to do is to go to your formula sheet, page number 4. You look for formulas that are written down to resemble this. Those are the possible formulas that can help you. Then after completing the square, you'll be able to pick the right one. So I have my formula sheet here. Then looking at the problem, the first possible formula we see has the integral of dx divided by a squared plus b squared x squared equal to 1 on ab, the term of bx over a plus c. So that's the first possible formula I'm saying. And you see I'm picking it because it's written to be integrating a fraction with the quadratic at the denominator, being two terms separated by a positive sign. Then the next possible formula I'm seeing on my formula sheet says the integral of dx divided by a squared minus b squared a squared being equal to 1 on 2ab, the limit of a plus bx on a minus bx plus c. So those are the possible formulas. Now the one I'm going to settle for will depend on what I get after completing the square, because when I'm done completing the square of this quadratic, you should reduce these 3 terms to 2 terms. If my 2 terms are separated by a positive sign, I settle for the first one. Negative sign, I go for the first one. The second one is solved. So let's now move on to the procedure of completing the square. The very first thing is to write your quadratic in order. When I say in order, it means I start with the squared term, which is 2x squared, followed by the negative 2x plus 4. So that's my quadratic. So the first, another thing you have to pick up from here is that this is not a quadratic equation, because it's not equated to any number like 0 or 1. It's a quadratic expression. So in that situation, the first step of completing the square is a little bit different. So when I'm completing the square of the quadratic expression, step number 1 says take out the coefficient of x squared. So the coefficient of x squared is 2. I take it out as a common factor from every term. So this is how I do it. I write down 2. Now to show that I've taken it out as a common factor from all the 3 terms, what I'll simply do is I'll take my 2x squared, which is the first term, divide by 2, that gives me an x squared. Then I take negative 2x, divide by 2, that gives me negative x. Then I also take 4, divide by 2, that gives me 2. So I've succeeded to take out the coefficient of x squared as a common factor from every term. And to confirm that what we've done is correct, if you want to multiply this 2 by x squared, takes you back there, multiply it by negative x, you must go to negative 2x, which equals to is 4. So we can now go on and complete the square. So when you're completing the square, the first 2 terms are always captured the same way. That is the quadratic term, which is x squared, followed by the linear term, which is x. They're supposed to be captured exactly the way they are. Then I can now complete the square by taking half the coefficient of x. So in this square bracket, the coefficient of x, the number in front of x is negative 1. So a half of negative multiplication, negative 1 will give you negative a half. So you can square that item, you add and subtract. So I've got negative a half, I've squared it, I've added it already, then I'll subtract it again before I write down my constant term. So once you do that, you say you have completed the square. So that is how you complete the square. So after completing the square, the next target is to write down that complete square. So in the square bracket, that complete square is hidden in this first 3 terms. So to write down that complete square, you only use the 2 terms amongst the first 3, the 2 with the squares. Those are the only items you bring down. So I'm going to bring down x, and the other term, don't forget it carries a negative. It's a negative a half. Then if you put a square on that in the bracket, they are the same thing as the 3 terms. Once you can do square negative by half gives me 1 over 4, which is negative, so I take 2 minus 1 over 4, so it's minus 1 over 4. On my calculator, that gives me 7 over 4, which is positive, so it takes me there. So I'm gradually getting very close to the 2 denominators. So for me to say I have arrived, I have to open the square bracket, allow the 2 to go in, then try to also arrange it to match that. Then I see whether I get separated by negative sign or positive, then I pick my formula. So looking at that, you see that in the arrangement, the terms with x are behind. So if I'm multiplying these 2 in, I must go to the first person, to the last person first. So I'll take 2 times 7 over 4, that will lead me to 7 over 2. So the 2 terms are all positive, so it means I must settle for the positive sign. Then when 2 gets into the square bracket, this is what we call the square bracket, it will stay out of the smaller bracket because you see the square is complete, which means nothing can get into it again. So I'll be having 2 into x minus a half on the square. So I've succeeded to complete the square, and I've reduced my 3 terms to 2, and the 2 terms are separated by a positive sign, so it's obvious I'm settling for the first formula, since they are not separated by a negative sign. So guys, that's how easy it is to complete the square. There is also another option of completing the square for students who find it difficult to go through this standard procedure. There is a formula which is written as 4ac minus b squared, or 4a plus a into x plus b over 2a all the square. Some students also prefer using this formula as M6 students. But the danger here is that you must be good in memorizing, because if you make the slightest mistake with this formula, then you're out. So if you want to use it, please make sure you're very good at memorizing. So all I need to do is know that this is my a into my b is negative 2, my c is 4. I substitute there, it takes me straight down here. So if you do that, I will just do the substitution, then you can confirm there on calculator. My a is 2, my c is 4, minus b, which is negative 2 squared over 4 into a, which is 2, followed by a positive sign. Then my a is 2. I'm taking my a, b, and c from there. Then I have x plus my b, and negative 2. So I have my negative 2 on 2 times a, which is 2 times 2, all that square. So if you were to verify your calculator, you will confirm that this first part should give you 7 over 2, then followed by a positive sign into 2. Then you see that the second part is actually showing to you that it's straightforward, because here negative 2 and we divide negative 4, divide positive 4 to give you negative half, just like you see there, all that square. So guys, those are the different options of completing the square. So now that I've completed the square, I have confirmed that this one, my final answer matches the first problem. I can just do the matching so that I'll be able to get my values for a and b, just like I can see for a square and x squared. So what I'm saying is that I will just write what I have done there, here, to get x minus 1 over 2. So if I'm matching it to the denominator of my formula, this will therefore tell me that this is a squared plus b squared and x. That therefore means in my formula, every a squared will be 7 over 2, b squared will be 2, and every x will be x minus 1 over 2. So in that way, I will simply say if a squared is equal to 7 over 2, then what is my a? You simply take the square root to get 7 square root of 7 over 2, because on the other side, you need to know what to replace a for you. Then you do the same thing for b. If b squared is matching 2, then what will be a b? It will be a simple root 2. So now, to be on the safe side, I will just copy down the formula I've settled for. So I'm copying down that formula the same way it is written in my formula sheet. Then I have 1 over a b on the right, the arctan of bx over a plus c. So that's So with this guys, you see you have completely solved this problem by the completing the square method. And I hope it doesn't look different to you because we started by declaring that this denominator, which is here, if transform it by completing the square to that one. So that's why here we are putting this one on the original function. Then the right hand side stays like that. As an insect student, there's no need bothering yourself simplifying. What you've done like this is enough. So the only little trick that you might put in this problem is maybe in the exam they can choose to put a 3 here just to see whether do you know what you will do with the 3. So if there's a 3 there, it doesn't affect the quadratic. So my whole procedure will still go on the same. When I'm using this method, I'll use this method. Then when I come to my final answer, I must remember to put the 3 there, or I can choose to put it outside because it's a constant. It can go out. If you put it out there, it's still okay. But don't forget that whatever you do to the left, you do to the right. So if I multiply the left by 3, then I'll multiply the right by 3. So guys, that's how simple it is. I hope that is helpful. Thank you very much.